Hello everyone. Today let's solve the problem coloring trees. Right. So this was asked in Codeforces round 369, division 2. Right. So you can just go through the question. It's easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Right. So what does the question say here? So first of all, just give me a second. 1 second here. Yeah. There are n trees in a row. Right. So 1 second. Just give me a second here. Let me choose different color. Yeah, there are n trees in a row, right? Some are pre-colored, some are already colored, right? Nothing but some are pre-colored here. Nothing but here C not equal to 0, and some are some are not colored at all, means some are uncolored basically, right? So in this case C equals 0, right? So this is fine. There are entries in a row. Some are pre-colored, nothing but C not equal to 0, and some are uncolored, nothing but C equal to 0 equals to 0. So we may color only uncolored trees using one of the M colors, right? So this is uncolored, right? So we may color the trees, color any uncolored tree using one of the M colors, using one of the M colors, right? So I'll just write here M. Painting I with the color J costs P, comma J, right? So painting I with the color J costs what it costs? It will be PJ, right? So this is fine. Now beauty is nothing but the number of contiguous same color groups across all the trees, same color, right? So there are some which are uncolored, right? So we will be painting using M colors. This one we know. Beauty is considered when number of contiguous same color groups across all the entries, right? So beauty, I'll just write here beauty. So this is fine. Beauty is considered beauty is nothing but the number of contiguous same color groups across all entries, same color groups, right? So I'll just give here same color groups, right? Beauty is nothing but the number of contiguous same color groups across all entries, right? So this is fine. So what is our goal, or what is our main task here? We have to color the uncolored trees. So beauty is exactly K. What we need to do? Now we know what we need to do, right? So we need to color the uncolored trees. So beauty is exactly K with minimum total paint cost. With minimum total paint cost, right? So with minimum total paint cost, or this one I'll just write here TPC, nothing but the total paint cost, right? This is fine. Now if it is impossible, then we have to return -1. This also we need to keep in mind, man. This is very important. If it is impossible, then we have to return -1, right? So this is the question. Mainly our goal is to color the uncolored trees. So beauty is exactly K with minimum paint, with minimum total paint cost, right? So that is what we need to do. Again, I'll just read out the question loud, and then we can just move into the this one input output part. There are entries. See here, I have explained first itself. There are entries. Some are pre-colored, nothing but this one, C not equal to 0, and some are uncolored, where C equals 0, right? So we may color only uncolored trees using one of the M colors, right? So we may color, what we can do, we may color only uncolored trees using one of the M colors, right? So painting I with a color J costs PJ, this one, right? So this is fine. Beauty is nothing but the number of contiguous same color groups across all the entries. See, beauty is nothing but number of contiguous. So this word is also a very important one. Number of contiguous same color groups, right? So I'll just write here CONT, this one, nothing but the contiguous same color groups. Beauty is nothing but the contiguous same color groups across all the entries, right? So this one, across all the entries. Our main goal we know, we have to color the uncolored trees. So beauty is exactly K, that this part, beauty is exactly K with the minimum total paint cost, with minimum total paint cost, right? So if it is impossible, then we have to return -1, right? If it is impossible, then we have to return -1. So this is about the question, simple, right? So let me remove this one. Let me come to the input output part here. So just give me a second here. We have this one 322, sorry, yeah, 322 000, and this one 1234, uh, as well as 56, right? So this one is nothing but n is 3. This one, in case of the terms that we have used in the question, so this is nothing but n. We have been given n trace, right? So this one is nothing but the n, and this one 2 we have been given, this is nothing but m, and this is nothing but here this one k we have been given 2, right? So n we have been given 3, m we have been given 2. Just give me a second, 1 second here, 1 second, 1 second, just 1 second, right? So m we have been given 2 here, and k we have been given 2, right? So cost they have mentioned here, this one, 1 2 3 4 as well as the 5 6, this is nothing but the costs, right? So what we need to find basically accordingly with the question, so we need to color the uncolored trees. So beauty is exactly k, beauty is exactly k, in the sense beauty has to be exactly 2 here. So we need to color all the uncolored trees where beauty is exactly equal to 2 with the minimum total paint cost. Main total cost they have given here 1 2 3 4 and 5 6, right? So we have to go with the this one minimum total paint cost that we need to keep in mind. So this is the input part basically, right? So output that we need to get here is 10. How we got 10, let's discuss that one with the help of the approach, right? So now I hope the input output part is completely clear, man. Same goes with this input as well, same goes with this one as well, and same goes with this one as well, right? I hope this part is completely clear. Let's do one thing, let's discuss the approach followed by the complexities, and then let's write the code, right? So I have considered the same first example within the question here. So we have already discussed this one. This is n, this is m, and this is nothing but the k, right? So this is nothing but the cost here, right? So this is nothing but cost. The output that we need to get here is 10. We know this one. We have already discussed this one. And one more thing, we will be going with the dynamic programming approach, right? So just keep this in mind. We will be going with a dynamic programming approach, right? Just keep this in mind. So let's go with the step-by-step explanation part. N we have 3, m we have 2, and k we have 2, and the cost they have mentioned 1 2 3 4 and 5 6, right? So we will be making use of the dp over the positions, nothing but remaining groups, as well as this one previous color to the left, previous color to the left, right? So we will try all the ways to color each uncolored tree. So first we have to go with the contiguous color groups, right? So with the minimum total paint cost, right? So that's what we need to do. So we will try all the ways to color each uncolored tree, right? That's what we'll be doing, adding the cost and counting a new group only when current color is not equal to previous color, because of the contiguous colors, right? Contiguous colors, right? In the question they have strictly mentioned that beauty is nothing but number of contiguous same color groups across all the trees. So that is the reason we are going with, we will first try always, this is fine, to color each uncolored tree. We will be adding the cost which is necessary accordingly with the question, and we will be counting a new group only when the current color is not equal to previous color, because in the question they have mentioned beauty is nothing but number of contiguous same color groups across all the entries, right? So this one we have to keep in mind. So we will be going with the iterations from 1 to 3. So I have not showed every iteration, so we'll be implementing in the form of this one, what do we call, I have just shown the calculation here. So I didn't went with I equals 1, I equals 2, I equals 3 like that, right? So here for I equals 1 to 3 iterations, the best way to get the exactly two groups is either we can just go with a 1 1 2. So this will be 1 plus 3 plus 6, right? And or we can just go with 2 1 1, right? Right, we can just go with 1 1 2, or we can just go with a 2 1 1, because in the input we have here this one. Just give me a second here, 1 second. Yeah, we have this one cost, right? So n we have 3, m we have only 2, and k also we have only 2, and we have to go with k equals 2. We have to match k equals 2, because goal is mainly to color the uncolored tree, so beauty is exactly k, right? So with minimum total paint cost means our goal is to color the uncolored trees, so beauty is exactly k. So we can just go with the two groups, right? So the best way to get exactly two groups is either it can be 112 or it can be this one 211, right? So it can be 112 or 211. So both will give us the this one 10 itself. So this will be 1 plus 3 plus 6, that is equal to 10, and this one will be 2 plus 3 plus 5. Anyhow, this is just the this one placement, this one 2 we have placed first, either, right? So this one, this will lead to same output itself, means this will lead to the same value in simple terms. So both will give us the 10, and we will be taking the minimum of 10 comma 10. So this will be 10 itself, right? So basically we are making use of the DP. Here the DP fills these transitions efficiently by pre-computing best or second best choices for the new group cases to avoid an extra big of M loop per state. So this is where this one, this is the pro or the advantage of using the DP basically, right? So we'll be making use of the DP that fills these transitions efficiently by pre-computing best or the second best choices, right, for new group cases to avoid an extra big of M loop per step. So this is the mainly optimization purpose as well, right? So we are going with the optimization part as well by making use of the DP here. So this is fine, man. Now, what will be the, so we are done with the approach part, right? So the minimum that we got here is 10, which is equivalent to the output that they have mentioned for the example one within the question, this one I'm speaking of. So our approach works absolutely correct here in this case, right? So as we are completely familiar with the approach, let's do one thing. Let's discuss the complexities part. So what will be the time complexity here? The time complexity would lead to big of n into m into k, this one I'm speaking of, right? So the time complexity would lead to big of n into m into k. So each state I comma j comma l, this one l is processed once, and new group transitions are accelerated using best or second best pre-computation per I comma j, right? So this is fine. So overall time complexity would lead to big of n into m into k. What would be the space complexity here? The space complexity would be big of n into m into k as well, right? So because we will be making use of this one, or we'll be going with a 3D DP array, we'll be going with a 3D DP array. Just remember this one of size nmk we have, right? So which will be of the size n plus m into k plus n plus 1 into k plus 1 into m plus 1 for the safer side, right? So this is fine. So we'll be making use of the 3D DP array of size n plus 1 into k plus 1 into m plus 1. So this is fine. So overall space complexity would quite obviously lead to big of n into m into k. So the total time complexity and the space complexity for the code that we'll be writing in the future would be big of n into m into k and big of this one n into m into k respectively for both, right? So we are done with the complexities part. As we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So let's start writing the code here. I'll just come to the compiler. So we'll be making use of the fast input and output along with the different utilities, right? So I'll just go with import java.input_output.star, and also let me go with import java.util different utilities. I'll be importing the utility package. So this is fine. So next, let's go with the class. I'll just give main. You can just give any name that is relevant to the problem, right? So now first part is we'll be considering very large number just to represent the impossible states in the DP. So I'll just go with, so let me leave, I'll just give here static final. So this one will be long. I'll just consider here infinity inf. This one will be long. As I've said, this will be very large number basically just to represent the impossible states in DP, right? So this one will be 10 to the power of 16, nothing but 1e16, right? So this is fine. Next, let's do one thing. I'll just go with the main method, man. So this is fine. Now I'll just give here, let me come here. This will be throws exception, right? So this is fine. Now, within the main method, first thing is we'll be going with the fast input buffered reader as well as the fast output print writer. So first thing I'll be going with, so this one will be buffered reader br, I'll be considering. So this one will be new buffered reader. This one will be new. Uh, Input stream reader. So this one will be fine. Let me go with system.in. So this is also fine, man. I'll just go with print writer. So this one will be print writer pw, or I'll just consider this is the output part, right? So I'll just go with out here. So this one will be new print writer, new uh buffered. So this has to be buffered writer, right? So I'll just go with buffered writer here. New output. This one will be stream writer system dot out. So this is it for the input output part, right? So next, accordingly with the input, what we need to do, we have here this one n, m and k, right? So 3, 2 and 2. So let's read n, nothing but trees, m nothing but colors, and k nothing but required beauty, right? So I'll just go with here string tokenizer. This is fine. This one will be st, that is equal to new string tokenizer. So this one will be buffered reader dot read line. This is fine. I'll just go with n equals integer dot parse int. This is also fine. String tokenizer dot next token. Yep. Now let me go with int n, m and k, right? So this one will be integer dot parse int. So this one will be string tokenizer dot next token. Again, this is fine. And k equals same. I should have copy pasted and changed this one. Uh, Variable name. So I'll just go with k again st dot next token. So this is fine, man. Yep. We are done with this part, right? So next, let's read the initial colors from C of 0 to n minus 1. Means 0 means uncolored here, right? C of 0 to n minus 1. I said 0 means uncolored here. Just keep this in mind. I'll just go with C equals here. I'll just go with new int of n. This is fine. Next string tokenizer. Let's go with the string tokenizer. So this one buffered reader dot next token. Sorry, it has to be read line. Buffered reader dot read line. So this is fine. Next, let's go with a simple for loop here. This will be int I equals 0, I less than n, I plus plus. So we have to consider iterated value of the c, right? So this will be integer, sorry, this one will be integer dot parseInt. So this one string tokenizer dot next token. So this is also fine. Let's move on with the next step. So we have to read the painting costs as well. Nothing but cost of ij here, right? So we have to read the painting cost as well. Nothing but cost of ij, which is equivalent to the cost to paint the tree I with the color j. J means 1 to m here in this case. So one thing, just note down here, costs are also given for pre-colored trees. We know this one, right? But those trees can't be repainted. That's also they have that sentence they have said in the question as well. Again, costs are also given for the pre-colored trees, but those trees can't be repainted. Just keep this in mind. Now let's go with we have to read the painting cost of ij, right? So first let me initialize here cost, that is equivalent to new int of n. So this one will be m plus 1. So this is fine for uh, int I equals 0. This one will be I less than n, I plus plus. This is fine, man. So within the for loop, I'll just go with a string tokenizer. Again, I'll just go with new string tokenizer. So buffered reader dot read line. So this is also fine. So finally, let me go with a for loop here. Int j equals 1, j less than or equal to m, j plus plus. So this one will be cost of I j, that is equivalent to integer %. So this is fine. We have to pass here string tokenizer dot next token. So we are done with this part. Next, let me come out of this one entirely. Now let's go with the DP, right? So as we had discussed in the approach, we'll be going with the this one size in the space complexity we had discussed, right? So we'll be going with uh, n plus 1 into k plus 1 into m plus 1, right? So let's go with the DP definition here. DP of ijl, nothing but this is equivalent to the minimum cost to the color trace from the index I to n minus 1, right? We know this one. And dimensions we have here is I nothing but 0 to n, j nothing but 0 to k, and l nothing but 0 to m, right? So I can just write it in this way. We have to articulate the same thing in the form of code. So I'll just go with long here. So this one will be dp new long. This one will be n plus 1 k plus 1 m plus 1. So this is fine. So let's do one thing. Let's initialize all the DP n into this one. INF past the last tree can't have positive groups left. So here in this case, we are initializing all the DPs, right? So let me go with the for loop here. This one int j equals 0, j less than or equal to k, and j plus plus. So this is fine. So this one will be arrays dot fill dp of n and j. This is also fine. So this one will be inf. This is fine, man. Now let's go with a base case. So here at I equals n, so and j is equal to 0. I'm speaking of the this one. What do we call comparison operator here? Value. I value is if when I value is equivalent to n and j value is equivalent to 0, groups that need groups needed cost 0 regardless of the previous this one, right? So what do we call that one? uh, Previous color, basically nothing but L here in this case. Right, so let's go with the base case here. Let's do one thing. Let's write it here itself. I'll just go with arrays dot fill. So this one has to be dp of n 0 as well as 0. Mm, this is fine. This is nothing but the base case. Next, we have to process from right to left. We know this one. Nothing but from the value I equals n minus 1 down to 0. Right. So let me write the simple for loop here. This one will be int I equals n minus 1 I greater than or equal to 0. So this one will be I minus minus. So this is fine. Within the for loop, what we need to do, let's go with here best. So this one will be long best equals. So we have to pre-compute the values, right? As we had discussed in the approach, we have to pre-compute for each j in 0 to k minus 1 the best and the second best values of this one dp of I plus 1 j color plus cost of I color. This is what we need to do. Means basically we will be making use of this one to quickly handle the start a new group transition for the uncolored trees, right? So also we will be excluding the case where the chosen color equals the previous color L, right? So because they shouldn't be equal, again in the question they have strictly mentioned we have to consider the contiguous same colors. They have stressed that one, right? So we have to consider contiguous same colors, right? So let's move on with the this one coding part. So this one will be best equals new long of k. This is fine. Let me go with second equivalent to new long of k. This is also fine. So this one now arrays dot fill best comma inf, this is also fine, and arrays dot fill second comma inf, so this is also fine. Now let's move on with the for loop. So I'll just go with for int j equals 0, j less than k, j plus plus. So within this for loop, let me go with one more for loop. This one will be int l equals 1, l less than or equal to m, l plus plus. So this is also fine. Uh, let's go with the value. Once I'll just go with the value v if we paint I with the color L, right? So this is nothing but value if we paint I with the color L and let's keep the L for the next index as well, right? So that's what we will be doing here, and then so that we can track the smallest number, smallest value, sorry, and we can shift the previous best to second as well, and finally we can update the best. So this is what we'll be doing. So we can just write this one first. Let's go with the initialization part, and let's go with a simple if and else if, right? So I'll just go with long here. uh, v nothing but the value as we had discussed. So this one will be dp of I plus 1, this is fair. So this one will be j, and uh this one will be L basically, right? So this one will be cost of I and cost of L, right? So let's go with a simple if condition here. If v less than uh, best of j, this is also fine. So what we'll do within the if condition, I'll just go with second of j. This is equivalent to best of this one j, right? So this is fine. Now best of j, let me assign this one to v, this is also fine. Yep. Now let me come out of this one entirely. So now we have to track the second smallest as well. For that, I'll be making use of is else if here. Else if v, if it is less than, we have already given second here, right? Second of j. This is fine. Then I'll just assign second of j to the this one value v, right? So we are just tracking the second smallest accordingly with the question. So let me come out of this one entirely. Now we are left with one main part here. Now we have to fill the dp of ijl for all the j in 0 to k and l in 0 to m. Means in simple terms, we have to fill dp of ijl for all the j and l, right? So again, two iterations here. So this one will be int j equals 0, j less than or equal to k, and j plus plus. So this is fine. Again, one more for loop here, int l equals 0. L, as I have mentioned, it is from 0 to m, right? So this will be j less than or equal to, this is fine, j less than or equal to m, j plus plus. Uh, so within the for loop, so let's go with the default nothing but here it is impossible until we relax via transitions, right? So let's do one thing. Let's assign dp of ijl to infinity. So we have considered the large value, if you remember, right? So in the beginning, this will be dp of ij as well as l. Let me assign this one to the infinity. This is fine. Next, let's go with a simple if condition. If ci, if it is greater than 0, so within the if condition, let's go with the case 1 or the first case. Tree I is already colored with a fixed color C of I. We know this one, right? If C of I is not equal to L, then we can start a new group at the I, right? So let's try to articulate the same thing in the form of code. Let me write the simple if condition here again. Nested if. So this one will be if j greater than 0 and C of I, as I've said, if it is not equal to L, then we have to start a new group at I, meaning I'll just go with dpi j as well as L, as we are making use of the 3D dp. This one I've said this one multiple times, right? So we have to consider the minimum value if you remember the approach, right? So I'll just go with the math.min of dp of I. This one will be j and this one will be l. This is fine. Now I have to go with dp of I plus 1. This is fine. And j minus 1. This is also fine. Uh, this one will be mm, just give me a second. C of I basically. Alright, so this is fine, man. Now, next is if C of I is equivalent to L, means the iterated value of the C, if the value of iterated value of the C is equivalent to the L, we have to continue the current group. Nothing but J remains unchanged here, right? So let me write one more if condition here. If C of I, if the value, if it is equivalent to L, then 3ddp again dp of I j l. So this one will be math.min of dp of I, again j, again l, and dp of I plus 1. This is fine. Mhm. This one will be j and this one will be l. Right, so this is fine, man. Uh, this is fine. Now, what shall we do? So I have written the if condition here. This is fine. Let me go with else. So here else, let's go with the case 2, right? So when tree I is uncolored, we can choose any color, right? We can choose any color. So let me go with simple if condition here. If I hope this works, man. Let's see. If L greater than 0, then I'll just go with dp of I, j, and L. So this one will be equivalent to math.min of dp of I, j, l. This is fine, comma dp of I plus 1. This is also fine. This one will be j and this one will be l. Uh, I plus 1 j l. So let's go with the cost. We have to go with the cost as well. We cannot forget the cost, right? So this one will be cost of basically I and l paint. So this is fine. Cost of I and l. Right, this is option A. Means we have to choose the color that is equivalent to L. Means we have to we cannot create any group, means no new group, right? So we have to pay the painting cost of color L, right? So only valid when L is greater than 0, means L value has to be equivalent to 0, right? There is no defined same as the previous this one color right here. So this is option A. One more option we can go with, nothing but we have to choose the color that is not equal to L, means we have to start a new group at I, right? So we need j greater than 0 here, right? So we can write the simple if condition for this. Means here in this case, when j is greater than 0, we can just go with the this one. Mm, we can just go with illegally allowed color that is equivalent to L in new group. So this step basically I don't understand, man, why we need this one. If this option A was enough, I guess. I don't know. Let's go with this as well. So I'll just write it. If you try to understand this one, see this one I can just write it in this way. So we are just choosing the color that is not equal to L. Means when j greater than 0, right? If j greater than 0, then this one, let me go with some random variable name here, c and d. So this one will be dp of I plus 1. This is fine. And j minus 1. This is also fine. This one will be l along with cost of I and l. This is also fine, right? So yep. Now yeah, let me come out of this one entirely. Just give me a second here. 1 second. this one I have went with cost of IL, right? So this is fine, man. Next, we want min over all the colors when t not equal to 1, right? So I can just write it in this way. Within this if condition itself we have to write, right? So I'll just go with dp of I j. I'm a bit confused for this one, option B basically. So this one will be ijl, not the k. Sorry, jl. K they have already mentioned in the input part. So this is fine. Mat dot mun of this one will be dp of I j l. Uh, this one I had to close here. Let me go with here dp of I j l, comma best. This one will be j minus 1. This is also fine. This is equal to cand. Uh, this is also fine. Then, so this question mark has to be here. We're just checking. So I'll just go with second. Let me go with second. Yeah, this one will be j minus 1. This is also fair. Mm, this one will be best of j minus 1. This is fine. Now we have written this one already, right? So just give me a second here. Mm, this is, we pre-computed best of j minus 1 as min over all the t, right? And also second of j minus 1. So this is fine. We must use the second of j minus 1 instead, right? So otherwise we can just use the best of j minus 1 as well. So that is the reason I have written like this here, this one, best of. Else I have made use of the ternary operator here. So yeah, let me make use of the space here. Let me give space here so that this looks good. So let me come out of this one entirely, man. So we are just done with this one. What do we call? Uh, One second. Just give me a second here. So yeah, we are done with the code almost. So we know that answer is nothing but the cost that is starting at I equals 0, needing exactly k groups with a no previous color, right? So previous color should not be present and it should be contagious colors of same group, right? So I can just write it in this way, out dot println. So this is also fine, and this one will be dp of 0 k, as well as this one is 0. This is equal to infinity. If it is, then accordingly with the question we have to display minus 1, right? So if it is impossible, then we have to return minus 1. That's what they have said in the question. Or else we have to go with dp of what we have done so far. We have to display the result, nothing but dp of 0 k 0, right? So it should be equivalent to the k, nothing but in the approach we had considered two groups, right? So we were able to consider only two groups because k was given 2 for the first one, for the first example, right? So we went with the group 112 and 211, if you remember, right? So that is what here. First, if dp of 0 k 0, if it is the value, if it is equal to infinity, if it is impossible, then we have to display minus 1, else we have to go with dp of 0 k 0. So this is fine. This is just the input output part. Then finally we are done with the coding part. So we have to flush the output. So I'll just go with out.flush here. You can just go with out.flush or out.close. Anything works, right? So both of them are fine. You can just use any one of them, right? So we're done with the coding part. Before checking the code with different inputs, I just want to copy paste the signature starter template. Just give me a second here. So I'll just come here. Let me paste the signature starter template. So let's concentrate on the this one. Uh, Logic part. So I'll just come here. Let me copy the input. The output that we need to get here is done. Let's check the same here. Oh, we have many errors, man. 22 errors. Okay. So here, this has to be cost. I have misplaced actually. Sorry. Yeah, I have misspelled this one. Cost line number 42. I have just used this one. I know this one. This has to be cost, right? This one here. This one. This is fine. Let me run this one now. Some of the errors has to be gone. Again, we are left with 21 errors. Only one error is gone. Okay. Oh, incompatible types long cannot be converted to the long this one. Line number 45. Just give me a second. Same thing here. And the same this one. For loop basically or outside the for basically. Long DP. We have considered this one long. Just give me a second here. Hmm. One second. So yeah, it says that we have to add one more this thing, right? Array. So this is 3D DP array we are making use of, right? So let me run this one. Yeah. Now 19 errors are gone at one shot, right? So the same thing here because of the array, right? So we are considering 3D DP array and I have mentioned only two arrays here. So that doesn't work that way, right? So this is fine. Now we cannot find the symbol. M has to be capital here. Line number 73. So let me come here. This is fine. Final one here is incompatible types again. What? What long cannot be converted to the boolean. So where am I using the boolean one? So this one will be uh, this is fine. Just give me a second here. Out.println, this is fine. Oh, this one we are comparing, right? If the value is equivalent to infinity, I have to mention one more equals here. Sorry. And now this has to work. Yeah, we are getting the output 1. So we have to get the output 10 actually, right? Somewhere we have done something wrong. Let's check what is wrong here. See here what mistake I have done in a hurry. So I have given here int l equals 0 and j I have considered j. Where is j? So this one I have already written. This has to be l less than or equal to m, right? Same thing goes here as well. We have to increment l, not j. So I just wrote this one in a hurry, so I typed J instead of L here. So this is fine. Now let me run this one. I hope this works. Yeah. Now we are getting the correct output one. This was the mistake basically. Instead of L, we had mentioned J here within the for loop, right? So this was basically wrong. So that is the reason we are getting the output one. So this is fine. Now let me copy this one. We have to get the output -1. This is impossible. So let's check. -1, yeah, -1 we are getting. So let me copy the input, third input. We have to get the output 5. Let's check here. So yeah, we have got the correct output, right? So 5. So finally I have copied this one. The output that I need to get here is 0. Let's check here the same. We are getting the correct output, nothing but 0 here. So this is fine. Now let me copy this one and let me submit the code here. This is fine. So this one C, right? So yeah, C coloring trace. So let me paste it over here. I hope this works for all the test cases, man. Let's see. Let's wait for some time. Running on test one, you can clearly see here. So let's wait for some time. So you can clearly see here, right? So we are getting the verdict accepted, right? So the code works absolutely correct, right? For all the test cases, we have made use of the 3D DP just to solve this particular problem. This is purely DP, man. Completely DP based question basically. So this problem is designed to be solved with DP. Basically, we have made use of the 3D DP, right? So 3D DP array. I mean, so this is fine, I believe, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.